How can I use the standard form and the factored form of a function to identify different things about what their graph would look like? So this is the standard form because it is written as like once you multiply it all out, and it's written with the degree in descending order. So like 3, 2, 1, 0. And from the standard form, I can find out a lot of information about the graph. I can determine the end behavior from its leading coefficient and degree. The leading coefficient is 3, positive 3, which means that this graph is going to have positive end behavior. It's either going to look like this or like this. It is going to be positive. The degree is 3. This is the degree. This is the leading coefficient. So the degree is 3, which is odd, which tells me that the end behavior is going to go in opposite directions. So these go in the same direction. This is an even degree. This is an odd degree. So my graph is going to look something like that. Opposite directions, and it's going positive. As x increases, y increases. I can see the number of terms, 1, 2, 3, 4, which is going to tell me that there's going to be something like 1, 2, 3, 4 little turns in my graph. 3 turns in my graph. And I can find the intercept, the y-intercept. The y-intercept is always that constant at the end. And that is one feature. These are 3 different features I can now use in my graph. The factored form is when you have your factors in parentheses, and I can find the zeros and the multiplicities of the graph. The zeros here, I would set it to 0. So I would have positive 2 and negative 5 as my x-intercepts, or zeros. They mean the same thing. And the multiplicities is what the graph looks like at each of those intercepts. And I can tell that based on the exponents that are here. So for x minus 2 squared, this is a multiplicity of 2, which means that my graph is going to look like a quadratic. It's going to bounce off either like this or like this. And for my other factor, x plus 5, the exponent here is 1, so my multiplicity is 1, which means it's going to look like a linear function. It's just going to look like a line when it crosses the x-axis at that point.